Now in this video, let us continue solving problems based on volume of cone. So here we've got a question. A cone of height 24 centimeters has a curved surface area of 550 centimeters square. Find its volume. So we've got two data here. The height is 24 centimeter and the curved surface area is 550 centimeters square. We need to find its volume. Now we know that the cone is like this. We have a right angle triangle inside, which we have the height here and the r here and then the slant height here. So using the Pythagoras theorem, we know that L square equals r square plus h square. So we have L square as r square plus height is 24 square. Of course, we have to assume that the radius of the cone be r centimeter and the height be h centimeter and the slant height be L centimeters. So we have here L equal to root of r square plus 24 square is 576. Now we have another data. Curved surface area is 550 centimeters square. Now the formula for the curved surface area as far as a cone is concerned is pi r L, which is equal to 550. Now we have pi as 22 by 7. We have r as r. And then we have L as root of r square plus 576. So in the place of L, let us substitute root of r square plus 576, which equals 550. Now, r into r square plus 576 equals 550 into 7 by 22. This goes to the other side of the equal to sign. So now we have 22 25 times gives us 550. So we have r into r square plus 576 equal to 25 into 7. Now we need to take out this root. We need to get rid of this root. So let us square both sides. When we square both sides, we get r square into r square plus 576. On squaring a root, we can get rid of the root. This equals 25 into 7, the whole square. So on multiplying this, we have r to the power of 4. R square and r square is r to the power of 4 plus 576 r square. Let us take it to one side. Let us take this 25 into 7, the whole square, into the left side. It becomes 25 into 7, the whole square equals 0 because we have nothing left on the right hand side. So now we have, or we can also write this, the whole square, as 25 square into 7 square. It's all the same. So let me draw a line here and let us continue the problem here. So we have now r to the power of 4 plus 576 r square minus 625 is the square of 25 into 49 is the square of 7 equal to 0. So now we have r to the power of 4 plus, now we can write 576 r square as 625 r square minus 49 r square. 625 r square minus 49 r square is 576 r square. So let us write 576 r square as 625 r square minus 49 r square minus 625 into 49 equal to 0. So now we have, here let us take, considering these two terms, let us take out r square as common. So we have r square into r square plus 625. And then considering these two terms, this and this, let us take out 49. So minus 49 into r square plus 625, because minus 49 into plus 625 is going to give us minus 625 into 49. So this is equal to 0. So now we have, considering these two terms on the whole, we can see that r square plus 625 and r square plus 625 are the same in both the terms. So let us take them out as common again. So when you take out r square plus 625, all you have left in this term is r square, and all you have left in this term is minus 49. So this is equal to 0. So this is the concept of factorization. We need to go back to factorization and see what happens here if you haven't understood this. Now, considering both the terms, if we take r square plus 625, we are going to get a negative value. So therefore, we need to consider only this one. R square minus 49 equals 0. R square equals 0 plus 49, which is 49. R equals root of 49. And R equals 7 centimeters. So we are done with one part of the problem. We found the R. What is required for the volume? Now for volume, we have V as 1 by 3 pi r square h, which is nothing but 1 by 3 into 22 by 7 into r is 7. So, and we have r square here. So therefore 7 into 7 into the height is 24. So 7 and 7 gets cancelled. 3 goes 8 times in 24. And we have, on solving this, 1232 centimeter cube. So therefore, the volume of the given cone is 1232 centimeter cube. This ends this problem. Let us solve another problem. Conical tent is 9 meters high and the radius of its base is 12 meters. Something like this, a tent to stay, which is in the form of a cone. So we just go into this and we just stay for the night. So this is 9 meters high and the radius is 12 meters. So yeah, it should be a wide tent, something like this. So the height will be 9 meters, radius will be 12 meters. So this is a more appropriate figure compared to this one. Now the question based on this data is, what is the cost of the canvas required to make it? If a square meter canvas costs rupees 10, that is, if 1 square meter of the canvas costs rupees 10, what is the total cost of the canvas that is required to make the complete tent? And how many persons can be accommodated in the tent if each person requires 2 square meters on the ground and 15 meter cube of space to breathe in? So now, the first question deals with the curved surface area of the cone, because it deals only with the canvas that is required to make the tent. So we have to work out with the lateral surface or the curved surface area. And another important thing is they're given only the height and the radius of the circular base. Now, as far as the curved surface area or the lateral surface area is concerned, we need the slant height, which we can easily find out by using the Pythagoras theorem. Now, the second part of the question deals with the circular base, because each person requires 2 square meters on the ground, which is nothing but a circular space. So we need to find the area of the circular space. And then if one person requires 2 square meters, divide that area by this 2 square meters, and then we find the number of persons. And the second part of the second question deals with the volume, because one person requires 15 meter cube of space to breathe in. This is the volume of the tent. This deals with the volume of the tent. So we need to find the total volume of the tent and divide it by 15 meter cube to also see how many persons can be accommodated. So this is the brief outline of the problem. Now let us go ahead and solve the problem. Now let the radius be r, which is 12 meters, and let the height be h, which is 9 meters. And using these two, we need to find the slant height, which is root of r square plus h square. I'm not going too deep into the working of this because we've done it a couple of times already. So let us quickly get through this one and find the value of L, which is root of 12 square plus 9 square, which is root of 225, which is 15 meters. So we found L as 15 meters. Let us go ahead and find the area of the lateral surface, which is nothing but pi RL. Pi is 22 by 7, R is 12, and the L is 15. So solving this, we have 565.7 meters square. Now, 1 square meter of canvas costs rupees 10. So how much is 565.7 meters square cost? It's nothing but 565.7 meters square into 10, which is 5,657 rupees. So the cost of the canvas required to make it is going to cost rupees 5,657 rupees. So here we have. Now let us move on to the second part of the question, which deals with the area of the circular base and the volume of the cone. So now the second part is area of the base of the conical tent, which is nothing but pi r square, because it is a circular base. So 22 by 7, r is 12 into 12, that is r square. So we have 452.16 meters square. So the available space on the circular base or on the base of the tent is 452.16 meters square. Now each person requires 2 square meters. So to find the total number of maximum number of persons who will have enough space on the ground will be to just divide the total area, which is 452.16 by 2, which gives us 226. That is approximately, we can have a maximum of 226 persons on the ground. Now this ends the first part of the second question. How many persons? It is 226 persons. Now again, we need to go to the volume of the cone. So here we go. The third point deals with the volume of the conical tent, which is nothing but 1 by 3 into area of the base into the height, which is, the area of the base is 452.16 and the height is 9. So we get the volume on solving this as 1356.48 meter cube. Now each person requires an air space of 15 meter cube. So we need to divide the total volume by 15. We get 90, 15 meter cube. So 15 goes 90 times approximately. So we get 90 here. So between 226 and 90, the smaller number is 90, because we need to make sure. Now the 226 people can get the circular base space, but then can they get the volume? Each person here cannot get a volume of 15. So now all the 226 persons can't definitely get 15 meter cubes. So it's more important for everybody to be comfortable. So we choose 90 person as the maximum number of people that can stay in this conical tent. So hence 90 persons can be accommodated in this conical tent.